Hi everyone, this is the 9th lecture. You can congratulate yourself, you're halfway through the material of this class. Today's topic is threats to validity and other issues. These are things that hopefully are somewhat of a review for you as you've taken other research methods courses. I just want to present this in light of what we've been doing with regression analyses. Today's topics are the 4 types of validity and threats to those. We're going to talk about measurement error, and we're going to finish with talking about reproducibility and replicability in research. This is a hot topic as of late, and we're going to talk about ways to improve the situation for you as a researcher and what to look for in other research. So the first topic, the 4 types of validity, those include internal validity, external validity, construct validity, and statistical validity. All of these are going to matter for this class. I know this is a statistical course, but even the construct, external, and internal are going to be important here as well. So as a reminder, internal validity is whether the studied relationships or effects are valid. It's about, is the experiment or the study, are those valid? It's an internal aspect to the study itself. The ways that we can have problems really come down to 3 categories with internal validity. We have omitted variable bias, which we've brought up before in this class. There are trends, and then there's calibration and contamination. When it comes to the omitted variable bias, how that can impact the internal validity, first is through selection. That's when the participant, instead of the researcher, can select their level or group. This means there are other variables inside or around a person that is helping them decide what level or group they want to be in. And if we don't control for those other variables, then we're going to have this omitted variable bias. The other one is attrition. That's when the participant chooses when to start or stop their participation. So if you're in a study where they can choose when to come in or when to leave, that is going to impact your results because there's going to be outside or internal forces of that individual or around that individual that is going to be helping them make that decision. And if we don't control for those factors, the results will be biased as well. What's important to remember is that the omitted variable bias is only a problem if either selection or attrition are based on another factor that influences the predictors or the outcome. So if it's something that is completely unrelated to your study that is the reason why they chose to stop or start, then it's not going to be an issue. But if it is related to any of the predictors or the outcome, it's going to be a confounding variable and will cause some omitted variable bias. With trends, we'll start with maturation. That is when change is expected naturally. So, for example, kids in schools, they are naturally going to be learning and growing no matter what. And so when we put an intervention in a school, it's really important for us to know, is this just because the student is naturally growing, or is it because our intervention is actually working? With seasonality, that's talking about when certain times of the year produce different results. For example, exercising in the winter. So exercising in the spring and fall can be really pleasant. People like to get out and go for jogs. Less so in the winter. And so if we're looking at something to do with exercising or health in general, we're going to want to pay attention to what season are we looking at this, because that could impact the results. The third is testing. This is when individuals improve just because they've taken the test before. It's also called practice effects. Honestly, this is not generally a huge issue in a lot of social science areas, because if people really just got a ton better just from testing, then we would probably just give them tests and that would be our intervention. There are some areas, especially in cognition and neuroscience, that practice effects are really important to pay attention to because they can uh, cause an individual just to do better just because they've seen it before. Another one is regression. And this is the idea that an extreme individual tends to be less extreme over time. You've maybe considered like if someone got really lucky or someone has a hot hand in sports. So what's really important with this one is you don't want to select participants based on extreme values. You don't want to look at their values, say, oh, this person is really extreme and this person's really extreme. Let's look at them over time, because over time they are likely to be less extreme no matter what else is happening. And then, of course, there's always some form of an outside trend happening. So outside trends like recessions or cultural changes, we need to be careful to note whether those could have an impact on the predictors or the outcome of our study. If so, then it's something we'll need to control for. The last area that we want to talk about with internal validity and threats to that is a calibration and contamination area. So the first one we want to talk about there is measurement error. We're going to talk about that in more detail in a moment. But note that it is part of this threat to internal validity. The second one is the time frame of the study. If the study is too short, then the effect may not have had time to show up, or if the study is too long, it may have washed out. This can be really tough when you're looking at the effect of something over time. You need to be able to measure things in the right time frame. This is often based on experience and theory that will guide you in there, but sometimes it's trial and error, just figuring out when is a good measurement time to actually find if there's any real effects happening. This other one called Hawthorne. This is when observing people, it actually changes how they act. This can be a problem because people tend to want to look a certain way when they're being observed, or they tend to avoid certain behaviors when they're being observed. And there's always ways around that, but it's really important to note that if individuals know that we're observing them, it may change their behavior just because of that one simple fact. And then you have spillovers. It's when the effects from one group spill over to another group. This can happen in a lot of situations, especially in experiments. And what you really need to try to do is keep any benefits from one group from ever reaching another group, at least for the time frame of the study. We don't want things that's happening to the experimental group to wash over into the control condition. In general, that really reduces what the effect size looks like in our study and hurts our statistical power. And then this last one, intervening events. And this is when something outside the study happens that is related to one of the predictors. This can be really anything that happens to a single individual or happens to a group of individuals that affects something about their predictors, something about their characteristics, and that will again introduce this confounding factor into the study if not controlled for. That is it for internal validity. When it comes to external validity, this is the idea of whether findings are generalizable to the entire population being studied. So internal validity was, are the results that we're finding, are they valid for the sample that we have? External validity is saying how much do those results actually generalize to the entire population that we want to know more about. And when you consider this, consider these various aspects of external validity. First is lab versus real world. Often in the lab, we can artificially create larger effect sizes than what we would normally see in the real world. So if your results are in the lab, note that it may actually decrease the effect sizes when it is not so tightly controlled. Another thing to note about that is the lab is very good at internal validity, but it often lacks the ability to really show a ton of external validity. The real world data, where you're just making observations, often has the opposite problem, where internal validity isn't so great, but external validity is great. The next thing to think about are study volunteers are often what are known as weird in all caps. Weird stands for Western, educated, industrialized, rich, and democratic. So we need to keep in mind that when we bring in study volunteers, including in Logan, Utah, that these individuals represent Western, educated, industrialized, rich, democratic individuals. And we shouldn't generalize to anything beyond that ever when we're using a sample that is weird. It's also important to remember that not everyone takes surveys. So even outside of just study volunteers, surveys themselves can be very particular types of individuals that are willing to do that. There's some research looking at who is willing to do that, and it's often individuals that have more time on their hands. So it's not going to be individuals that are working 5 jobs or 3 jobs and just making it by. Those people aren't generally very well represented in surveys at all. And then the last thing to consider here is, do results in Utah apply to California? I would say this is very dependent on what you're looking at, but it's really important to consider that if you're doing a study here in Logan, Utah, it's unlikely to represent the entirety of the United States. It may not even represent neighboring states. These are things that are often limiting factors in external validity when we're confined to a certain amount of funds, or especially research where you have to bring people into the clinic. It can be very difficult to collaborate with other clinics. But it's something, even when you have those limitations, it's really important that you realize that, so that when you're talking about your results, you understand that your external validity may be limited. When it comes to construct validity, this is the idea of whether you are measuring the thing you want to measure. This is one of the tougher things, and there's a whole class here that talks about how do we understand how good our measures are. The psychometrics and measurement theory class, that one really spends a lot of time going over what construct validity is, how we can look at it, and it also covers a lot of the reliability and other things to do with measurement. But one question, one example is, do school assessments test the quality of learning? I'm currently consulting on a few projects that are working with educational data, and often the measures that we have available are school assessment tests. And what we want those to highlight is how well the teachers are doing, or how well the school is doing. And we have to really consider, do school assessment tests actually measure any of those things? I would say in most cases, no. It may be a proxy, it may relate to those things, but it probably isn't measuring that. It is probably measuring 2 things in tandem: the student's knowledge and how good they are at test taking. And that is often fairly independent of school quality and even teacher quality. Last one is statistical theory. And this one is, are you using the correct statistics, avoiding p-hacking, checking assumptions, have enough statistical power, etc. So a lot of the stuff we're covering in this class naturally help us understand statistical validity. If we're doing things correctly and we're not doing things like p-hacking and we're checking assumptions, then often the statistical validity can hold. And that is an area that we often do have some control over in a study. Some of these other validities can actually be difficult to control. When you're doing a study, you want to consider each of these together and know which ones are more important for your current situation, for the research questions you have. So all in all, validity is all about how your results can actually inform the world, whether it's, do these results hold within the sample for real? Does this generalize to the whole population? Are we actually measuring what we want to? And do the stats actually tell us the reality of the situation? We need to consider all of those anytime that we're using any form of regression. It may not be front and center every time that you're doing it, but we should be thinking about these when we are considering what do our results actually mean. Next topic is measurement error. And this is when the measure is imperfectly measuring the construct. So importantly, measurement error is actually different than construct validity. Construct validity is asking, are you measuring what you think you're measuring? Measurement error is how well are you measuring that thing? How consistent are you measuring it? How reliable are you? They are two different things. So construct is, are you measuring the thing you think you are? And then measurement error is a problem that happens when we're wondering how well, how accurate, how precise is our measure of that construct. It falls into two categories. The first one's random. So this is when measurement error is just random. It just is happening. There's no systematic bias to it. There's not a certain type of individual that it measures better than another. It's just random. It just happens. And this, I would say, is probably happening all the time. In all of your measures, there's some form of random measurement error. It's just what happens, even if we were to measure someone's height. Just randomly, there's going to be slight deviations in how accurate our measure is of that person's height. When it is random, it reduces statistical power by increasing your SEs when the sample is big. So when your sample is big enough, it just is increasing your uncertainty. So you have less certainty in your results. When your sample is not big, random actually can do other things too. It can cause problems in other ways when you have a really small sample. And random happens when the reliability isn't perfect, but it's not, again, related to anything relevant to the study. So it's not related to any individual characteristics, any measures of outcomes, nothing like that. It's just random. Which leads us to the other one, which is systematic. And this one actually biases your coefficients and SEs. So your SEs in random are just going to be bigger. When it's a systematic measurement error, it biases your coefficients and SEs. And this happens when the reliability of the measure varies by other factors. So, for example, if we're talking about measuring someone's height, maybe we let certain types of people leave their shoes on while we told other people to leave their shoes off. That is going to introduce a systematic measurement error. Let's say also we didn't really account for hairstyle when we're measuring height. And so some people with bigger hair or no hair, their measures will be systematically different than each other. When that happens, it biases our results because it's like introducing another confounding variable where our measure is actually being confounded by something else. So of these two, Obviously, random is generally better. But it's important to note that measurement error is happening all the time. And there may be some systematic error in your results, and it's always good to just check. Check, are there any reasons why someone might be doing better on this or worse than this or higher or lower, given any conditions that shouldn't be relevant. So one final note about this is that the way that these actually impact regression does depend on whether the measurement error is in a predictor or in the outcome. So systematic, no matter where it is, it's going to bias your results. Random, when it's in the outcome, it's just going to reduce your statistical power. When it's in a predictor, it actually can attenuate your coefficients and makes them look smaller than they really would be if your measure was measured perfectly. So that is important to remember, that if you're worried about the measurement quality, the reliability of your measure, especially when it's in a predictor, it has the effect of actually reducing your statistical power, even more than just by increasing your SEs. So in some ways, it's like double the impact when it's in the predictor than when it's in the outcome. So when it comes to measurement error, we measure it with reliability. And you've probably seen some of these measures before, like Chromebox Alpha and the like. And this is, again, covered in depth in our psychometrics class. Reliability is a really important thing to look at with any of your measures. And our last topic, even though there's that review of causation at the bottom, reproducibility and replicability in research. These are two different terms that are highly related, but they mean different things in research. So there's many steps in the research process that can make a study difficult to replicate or reproduce. So importantly, reproducibility refers to the ability to obtain consistent results using the same data and same methods. So if you handed someone your data and told them the exact methods you did, reproducibility refers to the ability to obtain the same results. And using tools like R Markdown, like we do in this class, having code and output tied together, having good data practices where you are cleaning the data in code and not saving on top of data. You're not doing a ton of things in Excel. And when you're using data dictionaries, these are fairly easy ways to avoid reproducibility problems. And I'll tell you that there's nothing scarier than when you come back to something and you can't reproduce it, especially if it's something that's been published or is about to be published, and you're like, yeah, let me just see if I can get the same results. I'm just checking on stuff and it's not the same. That is time to panic. When we use tools like R Markdown, where everything is tied together, it's far easier just to go back in and see exactly what we did. We can re-knit the document and see, yep, the results are exactly the same. So reproducibility is really helped by using those approaches: R Markdown, good data practices, data dictionaries. When it comes to replicability or replication, this is often defined as the ability to obtain consistent results across studies aimed at answering the same research questions using independent data. So this is, they go out and collect their own data, and with their own data, they're trying to answer the same research question. And replication would say that we're able to get the same conclusion. It may not be the exact same values, but we should arrive at the same conclusion. So reproducibility and replicability. For our in-class example, we're going to talk about why most published research is false. There's an article out there that's called that. I do not believe that most published research is false, but the author brings up a lot of really important concepts that it's really important for us to consider when it comes to replication. So if you have some free time before we talk about it in class, go to why most published research is false, and it will be an interesting read at the very least. For further readings on these, There's these 4 links. They're all going to take you to different aspects of what we talked about today. We have internal and external validity. We have more on construct validity. We have measurement error and the reproducibility crisis. I recommend, if you have any spare time, go into these and get to know these better. This was just an introduction to these approaches. And I don't want you to feel like by just knowing this much, that's enough. I want you to understand that there's a lot more to these things. And of course, to learn more about measurement error, you can take a class. But the other things you need to really look into on your own, make sure you understand them well. If anything we went over today was confusing, these can really help. Also, feel free to reach out and ask about any of these topics. These are really fun ones for me to talk about. I enjoy the theoretical nature of a lot of these, and I particularly love the reproducibility crisis and what we can do to fix that. I am currently an ambassador to the Center for Open Science. And so I love talking about ways that science can be more open and how we can increase the reproducibility and replicability of science. Unit 2 is kind of unique in what it tackles. It's a lot of issues that are kind of on the side of regression that are really important. Unit 3 will get right back into actually using more regression approaches, and we will be talking about things like interactions, effect sizes, nonlinear relationships. It's one of my favorite units. I'm excited to talk about those shortly.